Alright, welcome back to Let's Play. Oh, wait, I don't do Let's Plays. Okay, right, we're gonna do the actual code now. Let's do. We need to get back into the. You know what? I'm gonna turn off this background so it doesn't drive you guys nuts. Much better. Much better. The Susan coffee, yes. She should not be covered up. Okay, let's go. Oh, you know what? Form 1. Awesome. Normally I change this as soon as I make a Windows form or a WPF, but I got distracted from recording, so let us definitely rename that to like main for now. Yes. Let's get rid of that shame. Let's go to the properties, get that form 1 off here. I hate it. It's so ugly. FX2 trainer, we'll call it. It's actually demo, I guess. I already made a trainer. Let's make it demo. Match the silly names. Okay. We're actually not going to need a whole lot on this form. Just a few buttons to do our cheats. There is a choice up to you. I'll probably do it the quick way. Yeah, I'm going to do it the quick way, but I'll just warn you guys that you shouldn't do it the way I'm about to. When you open your app, I'm going to have all the code to pull the process right away. So if you open the app and the game's not running, well, it's not going to do anything, and it's useless. So I have to open the app after I run the game, but you can have a button do it or just a timer to listen to it. But to save time, I'm just going to concentrate on the code that is pertinent to you guys. So I'm just going to have a on start basically method here. So alright, actually it's bugging me that I just dragged 2 buttons on there and didn't name them or anything. So let's just give them some max items. Let's give them some basic cheat things we would want. Max skill. And then I don't want to call them button 1 and 2. Max skill. Max items. BTN. Max items. Okay. Anyway, let's go back to the on start. And you guys can put this wherever you want. So, essentially, we need to instantiate a class. Since I didn't make our little process memory here static, we need to make, let's instantiate one. Memory process reader. Of course, I don't have it using utilities. And I don't know if I like that namespace anyway. Well, actually I'll leave in case that's what you guys are doing. Oh, screw it, I'll just let it figure it out. Memory process reader. Call it mreader. Okay, and then I will tell Visual Studio to use utilities if I spelt it right. And I did not. Did I even call it memory process reader? Not this one, this one. Ha! Other way around. Dyslexia wins again. Okay, now I can tell it to use utilities. Whatever. So that can be your guys' library. I'm not really going to worry about it. Oh, there's more. Okay, let's clean this up a little bit. So we need that because we're going to be using that to read and write memory. We're also going to need our offset. Actually, we're going to have a couple offsets. We're going to need the pointer address. So let's just make, because this is going to be custom to whatever your game, so you can put this wherever. I'm just going to make it here. P address, I guess I'll call it. Now let's go back to art money. You know what? I can hear the game. Screw it. I don't think it's too loud for you guys. That would drive you nuts listening to that. That frickin' music. Let's see. We want... Yes, this guy. Address in module. So, again, this is going to be important. I'll show you in 1 second, but we're going to copy this address here, and this is hex, so let's do that. You can actually do this too, but actually I will do that. So there's our memory and address. It is an integer, it's an unsigned int, so it's uint, but you can put stuff in as hex. If you don't, for some reason, like hex, I actually recommend leaving it as hex, but let's say you have you could always just flip it over to decimal. You can copy this big number in here instead of the x hex number, but I'm going to leave everything in hex. It's going to be a lot easier. I would recommend doing it because you're going to be looking at art money or whatever have you. So it'll just be easier. This, unfortunately, though, is a decimal or an integer. It's not a hex value. So, but let's ignore that for now. I still won't show you the importance of this yet. We'll do it on our open method. But for now, let's see. We also need this in a variable. Yeah, I guess we can be cheap. Let's just put that somewhere. -274. So that's not an unsigned int. That's a regular int. So I'm going to say p offset. Well, Not P for pointer, it's actually a pointer offset. So let's call it pointer offset equals -274. Right? Is that what it was? Yes. Okay. Now I think we have what we need. But I'm going to be cheap again because we're going to use these two addresses to get the actual address that we want. So I'm going to make, I don't know, I guess a uint. I don't know what I want to call this, just offset, I guess. Just going to be the offset. I should put it in capital letters. It's going to be 0 for now because we don't know what it's going to be. So let's get that value. We have to get the processes now. Again, I'm going to put mine in the main load form or method. Sorry, but you can put this wherever you want. So let's use some Windows. There's some typical .NET coding. We're going to get process, which I have to pull in from System Diagnostics. And let's see, P, and this is going to be process dot. Let's get all the processes by name. So we're looking for the processes currently running on the computer, and we're looking for this guy. So you can usually pull up your task manager. What the hell? Oh, processes. There it is. ffx-2.exe. Don't mind the 32. That's just this thing telling you it's a 32-bit process. And we don't need the .exe. So all we need is ffx2 or -2. So let's get it by name and let's give it ffx-2. Now it's going to give us a list, and I want the first or it's not a list, it's an array. No! I could do this, but that'd be dumb. Let's fine. Let's make it an array, and we'll rename this processes. Or so then we can either go down here and do if processes.length is greater than 0. But you know what? I like lists and I like link. Did I get rid of link? Oh, I did. I should have left that in there. System.link. Because what I want to do is to list, and then I can do my nice first or default. So this is going to give me, oh yeah, then we got to take it off array. This is going to give me one process back, and this can be null. So that's what or default means. I guess I should say first or null, I guess. Maybe that wouldn't be too correct there, but yeah, let's not make it plural. Damn it. Alright, so now we're going to have one process. So that's a lot better. I like that instead of doing the index-based stuff. So now we can say if it's not null, I can do stuff with it. So now that we have the process, we're going to give that to our memory reader that we instantiated up here. So we copy that. Memory reader. Let's see. What do we call it? Yeah, it was process or... Oh, we called it read process. I want to rename that. Whatever. So we set it to our process we just picked up. So let's look at that. Remember, we had this process. It's the same thing. It's the same type. We just had something that we needed to open and read from. We got the handle, so everything's tied to it here. Now we have it in this object. I guess really we didn't need to store it in here, but it'll be useful for you guys to access later. You don't have to keep it in your client. So we'll use this a couple times. Not much, but we'll assign it in here so we don't have to keep this guy outside of this method. This will just be used once and gone. We don't have to have another instance of it up here. We already have it in our memory reader class. So now that we have it, we need to figure out our pointers here. So after we assign it, first thing we have to do though, to do anything, is open process. Oh, there's a little lag there. And remember, all our open process did is, since we already assigned it to this, it runs in here, uses that DLL to open the process and get a handle back, which is private internal, which is fine because we don't need to look at this ever. So now it's ready to be... This will actually throw an error too if we have a problem. I'm not going to do error handling on this. Maybe I should, just for in case it fails on me, but I don't think it will. But anyway, now that we have it assigned, it's hooked in, we can start reading and writing memory. So the first thing we got to do is actually read memory to figure out the pointer, where we have to read every other memory address. Ow, just hit my hand on the table. So this is going to be a pretty ugly line. I might want to zoom out a little bit for it. It's probably going to be pretty long, but let's just do it piece by piece instead of chronological, so we can read through what we're doing. So we know we have to read memory, right? See, that's why I don't like call that read process. Damn it. We know the first address we need to read from is here. So let's plug in, actually let's look at the overloads again. It's an int pointer, so we're going to have to cast it to an int pointer. No big deal. P address. So we're trying to read from that pointer address. The bytes to read, well, it's a pointer, so it's going to be 4. We can just hard code that. Out. That's right, they got these silly out variables. You know what? I'm going to make one up here, like a dork. Bytes out. Because I'm sick of using those. I don't ever use those really, but we need to out bytes out. But anyway, so we're going to read the pointer. This looks like it is okay to return back. It's going to give us bytes. We'll worry about that later. But one thing I do want to call out, this is going to give us the wrong address. Even though Art Money tells us that the game address is here that we're trying to read the pointer from, there's one extra step in here, and this threw me for a loop. I had to figure this out on my own. It says address in module, and that is key. It doesn't say, well, I don't know if it ever say address in block or not, but I think all pointers are say address in module. So the important thing is there's different modules in this exe, and I'll show you. In fact, we'll use the debugger to show this, but the module we're running is ffx2.exe. That doesn't make sense to you because you're thinking that's a process. It should already be an LS Task Manager. We already know that that is the name of the exe. Well, inside the exe, there's different modules, and obviously there's an ffx2 exe, which is the one we care about, but there's other ones too, loaded modules from other things. So this address has to be inside this module. So we need to find that module. In fact, let me comment this out. If I put a breakpoint here, yeah, I think I can read it. I'll just show you quick. Let's start. Hope this builds. No syntax errors, yay. Okay, so here's our process. Let's look at, come on, let's look at the modules in here. You can actually go down here and read a bunch of stuff about your little exe here. But if we go into modules, yeah, there's, oh, let me turn that off, heck, sorry. Go back in there, modules. It says there's 90 modules loaded in this exe. And if it'll let me, oh, here we go. So here's all the modules. Right on top is the one we care about, but here's all these other DLLs and kernels and .NET and whatever the hell else it could be that it is using to run the game. So obviously we don't want to look in any of these. The first module though is ffx2.exe, so we're lucky there. But we do have to do something a little specific in here. We can't just point to this address. Luckily for us though, we can access what the beginning of the address is, so we have to add that, whatever that starting address is, into this. So I guess we're going to have to wrap this because we're going to have to do some addition here. So now we need to add that base module, right? So we have process. In fact, we still have it locally in here, so we don't have to use our MReader's version of it, this one. Let's just use process.modules, and we know it's the first one. You could do a lookup or whatnot. I don't think it's necessary for most games. I think the first module is always the right one, but whatever, I'm just doing it for the tutorial. And then we have base address, right? And that is that's already an int pointer. Do I have to, I think I have to cast that as a uint. Unless, can I add two pointers together? I don't know if I've tried that before. Let's see. Let's get that back. Does it say, the operator plus cannot be, makes me want to write an override for that, but whatever. Let's just deal with it. Cast it forwards and backwards. So we need to cast this as a uint, so we can add it to our other uint, and then the whole thing is being converted back into an int pointer. So there we go. We're going to now read the correct address for that pointer, and we're going to get it back in bytes, which we have not assigned yet. So this is where you could do your byte and say, okay, the memory reader is going to give me back the bytes. Unfortunately, we know this has to be a number, and so then we'll have to do a conversion from that byte. So instead of even assigning it to a byte like that, I'm not going to bother. I'm just going to convert it right in this one line. This is why I said this line's going to get a little crazy. So to do that, use the nice little native bit converter and say to int bit converter is nice. It pretty much turns all your bytes to and from types. So in this one we want an int, and it's a 32-bit int. So we just wrap the whole thing, because those are the 4 bytes it's coming back as, into a byte. You can do this in different steps, and it's okay. What is this bitching about? Oh yeah. So this silly thing requires us to say, where does it start? Well, I'm giving you 4 bytes. It should start at 0, but too bad they don't have any overloads for not passing that in. But have to tell it out of the 4 bytes, yes, start at 0, because again, we could be sending it a huge block of memory, and we only want, you know, the first 4 bytes, the last 4 bytes, whatever. So just have to deal with the silly options, I guess. So now this is going to return us an actual integer. So now we can actually set it to offset. Finally. So offset equals that. Uint. Oh, I think I used the wrong one. To u. My bad. I used a signed integer instead of an unsigned integer. But we know we only want a signed integer here, or an unsigned. Sorry. Yeah, and then we go. So we have finally we have the address that we want to start reading memory. This, again, if we follow these numbers, which I pasted in, yeah, this told me we aren't using these. I am using this. Shut up. Follow those numbers. We'll be finding the start of the save. Remember, I looked at this number. This is the start of the save in memory. So we're looking at this address in this module. We're getting this back down here in our offset, and then we'll have to add in. Oh yeah, we'll have to add that in too. The you know what? I don't think I'm going to bother with that. Well, I guess we could add it in right away. Yeah. Yeah, let's add that in right away. Otherwise we'll have to add it every time we want to read something. So take this address, blah 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 blah. Then screw it, I'm just gonna do it on a new line. I don't care. Offset, we're gonna minus equal it to the, I call it the pointer offset. And of course the different types. Oh right, and this is signed. So this is, I'm gonna do something really silly here. Because I are smart. Not. If the pointer offset is less than 0, aka negative, then I'm going to minus equal. So yeah, I could add math.absolute it. Oh, I think I just cast it to a... No, I don't actually remember. Well, I'm going to try it. I don't remember if you can do this or not. Because it might just cast into either 0 or a much larger number, which I don't need. Otherwise, we're going to add it. Yes. Cast. Well, I'm going to have to run through this. We already have a breakpoint. Let's figure this out. Let's see if it matches up. We'll skip over that. Okay, let's get our offset. I'm going to switch it back to hex so we can compare it to art money over there. D19582. Let's see if that matches over here. It does not. I think we read from the wrong address. Let's see. That looks right. Oh, actually, I don't think art money's going to tell us that. That's probably right. Actually, let's keep going. I don't think that'll actually match up. Let's take it off hex again. Can't tell what that is. Oh, actually, I'm going to use the watcher immediate window. I want to see what happens if I cast pointer offset as a uint. Oh yeah, don't want to be doing that. Son of a gun. I guess we're going to math absolute that. In fact, hang on. I have my old program up somewhere in here. What did I do? I did do that. What? I'm not sure how that worked. That shouldn't have worked. Oh, I'm going the wrong way. Haha, it is down here. I did do it in math absolute. Okay, previous me. I will trust my my previous code there. So I'm pretty sure it works since I did get it to work. What are we doing? Less than 0. This is the one we have to math absolute. Whoop. Math.absolute. So we're changing that negative into a positive, essentially, is all we're doing. And then there we go. Now, let's try it one more time. Alright, skip over that. Get our offset. Okay. Oh, back to hex. Now this should be the start of save D194DO. I don't know if that actually matches. Oh yeah, it's down here. And right here. Okay. We're good. So, that all matched up. The only problem is we can't see these numbers too much because they're inside this module. ArtMoney kind of hides this, the number that we were looking for. But in the end, we can see that, hey, we're reading from the right address. So now, our offset variable is set to the beginning of the save file. So if we look at any of these save files, this is in memory and this is what we can read. So now, when we map out what the save file has or something in memory that we want to do, we can read and write from it. So, let's do, I guess, Gil, because that'll be the easiest one to do. In fact, we'll just go look at ArtMoney, so we got it all here. So Gil is plus 3470 from the offset. Oh, I know why I did this. Ha! Because this already... Damn it, I have to take off the 274 from this. Is that really what I did? Let's look at my old code here. You see all the cheats I did. Max items. Here's max Gil. So I added... Oh, I used hex numbers. Damn me. Fine, let's figure out what that is in hex. F5 hex. What number are we looking at here? 30... Oh, sorry, we gotta go back to decimal. I want to see what 470 is. 7706. That doesn't match up, does it? Gil? Did I click on the right one? I think I did. Yeah, it says right up top there. Gil. Duh. So, 7706. What's the difference of that? 7818 minus 7706? 112 bytes. Oh, the 274. Yep. So, that's the problem. We have to take any number we see out of here and add that silly 274. This is kind of a dumb pointer. Maybe I should use the games pointer, but essentially that's what we have to do. So let's take this number. Let's just start over here so we know what we're doing. 3470, so we know that's where Gil is the offset from our save in memory, and let's add 274 because that is where our save is. And if we hit, yep, 7818 just to confirm. Maybe I used hex because this looks like a harder number to read. I use hex a lot, so I'll continue using hex. So we know 7818. Now let's write this. Oh, we can write from scratch, or I can just copy it. I guess we'll copy it. And now let's go hook up one of our buttons. Max Gil. Voila. So let's take a look at what we're doing. We're calling our MemoryWrite pre... Oh, look at that. Oh, I named this something different. Let's fix that. What did I call it? Bytes out? Yes. And, oh, something's different. No method of blah 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 could be found. Did I name that something different? That's the problem with... Yes, I did. Just called write memory. Fine. Guess I should have wrote this from scratch, huh? Alright, so let's look at it now. Now that's all not red squiggly. Write process memory. As we remember, we pass it an address, and we have the beginning of the save. Maybe that's what we should call that. Save offset. And we're adding where in our save that we want to start writing to, which is we found the Gil was stored at this number. So we convert it into hex. So add those together, and that's the address we want to write to. Here again, I'm using bit converter. This section, or this variable, is what we're writing, and it is the array of bytes. And that's why I love bit converter. You don't have to set up your bytes at all. You can just convert stuff that you want. Like this is a lot easily written. We can just write our integer of 9999 for Gil, and just tell bit converter to convert that to bytes, and then whatever type you pass in, it figures out how to write. And then of course the out, which we don't really use. So when we're all done with this, remember our little method here is super simple. It just writes to that handle where we want it to, the buffer, the bytes really that we passed in, which bit converter gave us, and then we tell it, duh, we want to write all of the bytes that we passed to, not part of them, and then the stupid out variable that we don't use. So let's go back. This should work now if we hook this up. Let me confirm that I didn't already do that in this save, or we'll have to reload. Oh, it's okay. It's a couple nines less. This is only about 1 million. This is 999,000. So if we run our app, and again, this is one of the nice values that will just update immediately. Where the hell did the app go? Hey, Visual Studio. Oh, damn it! Take that breakpoint off. All right, now we got our little silly app off to the side here, and we'll watch this value. We hit max skill. Hey, and it worked. Direct memory injection. A little bit of Game Shark, old school going on right on a PC game. And there you go, in C#. You can do this. For the hell of it, let's do max items because that is a slightly different one. This is just one number. This is where you can start using your C# skills to do loops and whatnot because items, of course, require a bunch of looping. So let's figure out what that value is for items. I hope I have a location for that somewhere. Item IDs. Yes, that's what we want. So here's our number. Alright, let's get the little hex calculator out. F6, go to decimal. 3830 plus our stupid 274. And there's our number, 7980. So, let me just copy 7980. Now, so we know, let's actually go into memory. Take a quick look here. Item IDs. And pull up the game, side by side. Go to items. So, this window doesn't fit. There we go. In this game, items are actually 2 bytes. So we can see a pattern here. It looks like it's matching this. Quick little lesson on this game's items. Sometimes they're just 1 byte identifiers, like 0 is potion, 1 is Phoenix down. In this case, it looks like, as you can see, the 2 numbers are always some number and 20. So 20 is some kind of identifier to say this is a usable item instead of like equipment or accessories, something like that. So we know the number that we have to change, like 0 is potion, 6 is Phoenix down. We can just, actually, what are we missing here? Let's go put a 1 in there. We don't have a 1. So let's just test it out, make sure. FF looks like it's just, like FF0 is an off. So let's put a 120. Let's find out what that is. And again, this memory isn't going to update right away in the game. But as soon as I hit cancel there, you see the high potion 0 just showed up. So we added the ID, but not the quantity. And the game actually doesn't freak out about it. It just shows, okay, fine, you have a high potion with 0 quantity. So we know this is what we want to change. And we'll just have to remember it's 2 bytes each. So let's write a method. I wrote one over here. Max items. Yeah, let's just do this. It's quicker than watching me write. Bore people. But let's walk through it, obviously. So 68. Oh yes, I have to do all this though. Write memory, is that what I called it? And bytes out. I forgot. Oh no, I hit S. What the hell? Int. What? Bytes. Oh, I don't have to put int. Okay. So this is. Let's look at this. So I'm doing a for loop twice. Don't watch this one yet. This is 68. I must have figured out somewhere in the game. I must have counted these. Actually, can I go down? Manual. Yeah. So I must have went through here and found. Okay, there's 68 of them, or could just looked at art money and counted like how many of these there actually are, divide by 2. But anyway, found out there's 68 items in the game, or sorry, slots that you can carry. So doing a for loop here, and here's our offset. Doing an I times 2 because it's every 2 bytes we need to change a number. And here is a little different. I am not using bit converter on anything. I'm just creating bytes on the fly through this loop here. So I create a new byte array, and I pass it the I, because we're going through, well, every item in the game, I guess. I'm going 0 through 68 or 67. And so now we're going to write everything in the game. Sometimes you'll find weird items come out that way, but I think this game's fine. And then 20 we know because that's just what the identifier was. So here's my crafted little 2-byte array. Goes through here. It's going to be 0, 20, 120, etc. And then of course our stupid bytes out. So we're going to do this every 2 bytes. I'm going to write these and we're going to do it for 68 slots. And actually the bottom one is just quantity. So if I went down in memory, we'll find the quantity is just below it, usually, like most games. It's right there. Nope, that's not it. Actually, 99? Is that our quantity? What do we got? Oh yeah, because I changed it. Yeah, that's our quantity. And these are all 1 byte each, so we don't have to do anything crazy fancy like we did up there. Not that it's too hard, but But yeah, there's our quantity. So down here we're going to be writing for 68 times. We're just going to be putting 99. So I just create a silly 1 byte array of 99. But our process MemoryWriter will use it. So that should work pretty easily. Let's just test it out. Keep this window open. Fortunately, this is the one that doesn't update right away, so once we hit it, we're going to find nothing really happened. But as soon as we go back into it, voila! Game had to refresh that section of memory, and we have 99 of every item in the game in this items section. So this is pretty simple. Gives you a lot of power in the game to go around and play around with, because like getting these items, yeah, forget it. But there's one thing I do want to... Oh, I should probably talk about the actual number 99 here. Probably some of you might be wondering, why not do 255? And actually, I did when I started, so let's go down here and do 255. Ah, yeah. I'm running. Okay, Shift F5. 255. I'll show you what happens. Some games can break when you put on memory and or like bad memory values and stuff, but this one, it's not a bad memory value because obviously it's a number that computers should know. It's a max byte. So if I go to manual, yeah, look, it worked. The only thing is, a lot of games will recalculate stuff out of memory and do, keep things in range of where it should be. So if actually, I wonder if I organize it. No, didn't do anything. Damn. If I use any of these items, it will reset the count to 99, or 98, I guess, if I used one. Unfortunately, I don't think I can use any of these items, can I? I'm probably full. Damn it. Oh, I can use... Nope. I have to go get hit or something. Can I use anything out of battle? Aw, man. Well, you're going to have to trust me. Because once I use one of these items, that particular item will go back to 99. Not the whole lot of them, just that one. So you might as well just max it out to 99 since the game's going to recalculate it anyway. Plus, I don't know about people that are cheating or not, but even though I went through this game cheating just to figure out the game completion flags, I still feel like, I don't know, I still feel better if it looks more legit. Not trying to hide anything, just I feel better than, I don't know, I just generally don't like hacking or cheating in general, but, well, I guess I could show you the accessories. Let's do one more. Let's do an accessories button. Oh, this form is so retarded. That's okay, we don't need it. Accessories. Okay, fine. Just call it accessories. Let's give it a name. Okay. Now. Actually, let's copy. I'm going to save some time. Max accessories. The same thing. It's another section of memory where the items, just like the items, it's got the IDs and the quantifier. Or, sorry, the qualifier. There. Quantity. I keep thinking of a different game. Bytes out. And, yeah, bytes out. Change all this stuff back. At least it's better than writing it from scratch and have you guys wait. You just have to wait for me to correct my silly inconsistencies. So, accessories must be 128. Let's just go take a look before we cheat anything. Yeah, I've got 2 lousy accessories in here. So this is going to go through 7 CCO and 7 DCO. Yes. So, probably don't have to confirm this with you. It's in here somewhere. I have quantity. I don't have IDs. I probably should have saved that. Oh well. 3191.8. Okay. So, again, I'm using 99, not 255. That's right. These... let's go to... That's what I was going to look at. Let's go take a peek at the memory. But this is quantity, so let's go up. Here they all are. It's a nice round section, or I should say square. Here's our 2 accessories, and as you see, 2 byte identifier, these are 90s. So we're writing the exact same thing as this, except a 90 is our quantifier, and then 1 of every item in the game for 128 slots. So let's just check out. That should just work. Getting close to my actual trainer that I wrote. Max accessories, no errors, yay. And, uh-oh. It didn't work. Oh, I have to refresh it that way. Okay. So now we have 99 of all of these guys. Which, in this game, accessories are, like, mad. They are what make you powerful. So there you go. That's the basic gist of it. I don't know if I'd have any other tutorials. I mean, really, it's the same thing. You either loop through and put a bunch of bytes in there, like for items. Otherwise, everything's like one number: your level, your stats. Unfortunately, I won't show you stats in this game because how do I get to them? Equipment. Yeah, here. Stats over here, because this is one of those weird games where you could write a method to go in here and change all these to 255, which I have done, but as soon as you exit out of like this window or you do anything with your character, it recalculates all your stats. It's one of those games that it drives all off of your equipment and attached job, well, they call them dress spheres, and accessories, so there is no saving of stats. Like you don't have items that permanently increase them forever, so you don't need to save them in the save file. Well, actually that's not true. They do save them in the save file, but only for loading purposes, I guess. As soon as anything happens, they recalculate all this stuff. So you put 255 across the board, and you go into a battle, or you change your equipment, or just come into this menu and exit out. I think it flattens them all back out to where they should be, these values. So really, there's not much else to know. Experience, just a number like Gil. It's basically those two things you're going to be doing. What do I have on my... let's go check what I got. I have max items, max accessories, we did that, max skill, we did that, max abilities, oh yeah, that's another 2-byte array of ability points. That one's pretty easy. Maybe I could show that off quick. Key items, exact same thing, different part of memory. This one in fact only had a few. Oh, actually maybe I'll show you this one. These are flags. Yes. Alright, I'll do max key items. I don't even know if this is like all key items or not. I'll just show you this one quick though because they're flags. I need a new button. Oh, I have clipboard uses the other one. Whatever. Drag this on here. Key items. And because I'm OCD, I have to name this. I just hate to see button 1. And this isn't really matching any consistency anyway. Why do I care? It's just an example. Paste. Change all this stuff around. So with flags, if you're not familiar with them, they can be used, and this is what's going to look weird to you. This only looks like what, 4, 5, 6, 7, 8, 9. Oh, could have just used that, idiot. 9 bytes. So you think there's 9 items in key value, or sorry, in the key items menu. Let's go take a look. Actually, I probably don't have any this early in the game. Ah. Oh, I have 2, 3, 4. Oh yeah, they're all bad primers. So there's a lot more than 9, obviously. So you're probably wondering, how does this work? If you don't know flags, it's probably going to blow your mind. No, I'm just kidding. I'll just show you quick. Flags are a little different. They have 1 bit per item, and that's all you do is turn on, hey, I've got this item. There's no need to have a quantity or anything. So max key items. How do I get it to reload? Let me go all the way back out. Or this might not be working. Oh, there it goes. So, and I have all the items in the game, just from 9 values. So essentially, let's look at the top 8. 1 byte has 8 bits. Little known fact, haha. So it can have 8 flags for you have these 8 items. So these first 8 is 1 byte, and that is represented down here by this FF. That's max. I'll just show you. Max and hex, clear, FF. So here's your, actually I could go, here we go. There's your flags turned on. You can actually use a calculator to turn them off and on. But say let's take off the first one, or it could be the last one, 7F. I'm going to change that right here, and then run it again. Say key items. Now I should have 1 less item in the game. Let's see, how did I have to go all the way back out? Refresh it. Okay, whatever order they have it in. Oh, this is right, actually. It's generally stored backwards, I guess, from how you read it. What I should have done is probably turned it like that, FE, and then I would be missing this one. So as you can see, flags just line up. There's 1 bit per item. So that's one other thing you could do or run into where you need to turn on flags. In fact, if you're doing anything with like events or I don't really know what else besides key items, you'll be using flags. So you'll probably have to spend some time figuring out what each flag represents. In this case, they were all like nice and sequential, but a lot of times in games you'll find sloppy work and the flags could be like all over the place. In fact, speaking of that, I will show you the game completion flags in this game are located at 222C, and this entire block for the next 4,000 byte, well, 4,000 in hex, I don't know what that makes. Whoa, 4,000 hex, for the next 16,384. But, where'd my cursor go? For the next 4,000 bytes here, I'm going to go up to 622. These are all, oh, maybe I should use an earlier save, sorry. Go to an earlier save, you'll see more. This entire area is saved for game completion flags. And here, we finally see some values. 20s, 2s, 10s. These are all flags. This is one flag, the 20 flag. Let me get out of here. Let's go to the 20 flag, which is 32 in hex. Go back to hex. There, 20. The 20 flag, that's one bit, or one flag turned on for the game completion. This is such a waste of space. It is so weird, but you can easily write a program to go through here and like pick up all these, either read them or set them all or whatever. But this is a weird, I haven't seen this before, but this is a weird programming technique I've seen in a game. But like this entire section all the way down to right about, oh, actually let me use page down, we're still far away. I went backwards. All the way down to 622C, which is, I just passed it. All the way down there, that entire section, right up to about here. Oh, this shift didn't work. All the way up there. That was all just one section full of game flags. So you'll see weird stuff in games, how they store them. It's not always a nice way. It's kind of a weird way. But at least this gives you the skills to start playing around with that. Use Art Money, PC Engine, something. Start playing around with the memory, just going in here and, oh, we can see what my app did. And what the hell are all these 99s? Oh, never mind. That's the section of quantity. It just looked weird. We see what our app did right in the memory. It went through here and added these in, 0.99, 1.99, all the way up to the end, 7F90, and then added in the quantities. But yeah, just keep playing around memory, figure out what stuff means, and then start writing your apps and just hack away. It's a lot of fun. Alright, I hope that was helpful to some people. I'll see you later. Peace.